Hey class, this is Mr. Johnson here. Today is August 24th, and it's a lesson on solving absolute value equations. Mr. G would have gone over this with you in class today, but I'm covering my own video just to make sure that everything is covered. Concepts you need to understand. When you're solving absolute value equations, absolute value represents the distance from zero on a number line. So if I see the absolute value of 3, I just call that 3. If I see the absolute value of negative 3, it's also equal to 3. I'm just asking how far is the number inside of these bars from 0? How far is the number inside of these bars from 0? Negative 3 is 3 away from 0. 3 is 3 away from 0. Most of our problems in absolute value equations could be sort of described as, in a real-life situation, measuring the difference between a real count and a predicted amount. We'll see some examples like that. You'll commonly see those sorts of things in polling. We'll refer to a real amount we're actually interested in trying to find, a predicted amount or an average amount that we might have already known, and how far off, what's the error of our guess. Our predicted is often our average or our guess for something. How far off is how much above or below our predicted number we were dealing with. There are 3 cases to consider when solving. First case is if the absolute value expression equals a positive number. If our absolute value expression equals a positive number, we will have 2 solutions. An example equation would be the absolute value of x minus 10 equals 4. A way to imagine this question is it's asking what numbers are 4 away from 10 on the number line. If our absolute value expression equals 0, we'll have one solution. An example for that might be the absolute value of x minus 5 equals 0. If I was to see a question like this, I'd be asking myself, what number is 0 distance away from 5 on the number line? And if we have an absolute value expression equal a negative number, we would say we have 0 or no solutions. An example you might see for that is x minus 8 equals a negative 4. And the reason for this is that since our absolute value represents a distance from 0, we don't think of any distances as being negative. Somebody could be 5'5" tall, 5'7" tall, 6 foot tall, but no one's negative 5'5". No one's negative 6 foot. No one walks negative 3 miles. There's, in problems like this, no such thing as negative distance. So if we see an absolute value equal a negative number, we know that that problem has no solution. We'd sort of ask ourselves, if I was to see this, what number or what numbers are -4 away from 8 on the number line. We'll draw we'll draw 3 different pictures of what these expressions might look like. First one, we're going to put 1, 2, 3, 4, 5, 6, 7, 8. We're going to put 8 little marks on here. 4, 5, 6, 7, 8. And we're going to number them starting at 6. I'm going to skip one, count by 2 to 6, 8, 10, 12. I needed one more. 14. Thought I needed one more. Yeah, 14 on our number line. Now, if I ask myself what numbers are 4 away from 10, I could put my pen at 4 and count 4 up. 1, 2, 3, 4, and that would be one of the points we'd want to graph. I could also count 4 down from 10 and go 1, 2, 3, 4, and get another solution of 6. So 6 and 14 would be solutions for this problem. If I'm dealing with the one solution situation here, I'll have it a little bit easier in a different number line. I'm going to put 6 little tick marks. We're going to number them 0, 1, 2, 3, 4, 5. We're asking what number is 0 steps away from 5 on this number line. So I'll put just a dot at 5 because only one number has no distance from 5, and it's 5. 5 minus 5 would be 0, and the absolute value of 0 is 0. That would be our solution for this picture here. For when we've got no possible solutions, we're just going to say, most of the time, no solution. Another way you could indicate that as a reminder is you would put a circle with a diagonal line through it. Circle with a diagonal line also means no solution. We would have nothing on our number line to mark. Continuing on with this, I'm just going to be making sure to do the examples. We're going to do examples 1, 2, 3, and 4. I will have a separate example. I'll have a separate video for the problems where you have tried out the work. Depending on the size of each song, Luna's phone holds an average of 2,000 songs, give or take 250 songs. We're asked to write and solve an equation involving absolute value to find the maximum and minimum number of songs that Luna's phone can hold. And we're also going to graph the solution set. That's what we'd call these graphs here. These would be graphs of solution sets. First things I sort of want to identify are my averages or my predicted amount of songs. Predicted amount of songs we think we can hold, or the average number of songs we can hold, is 2,000. And how much could that vary? Well, we could have 250 more, or we could have 250 less. So how far off we could be? We could be off by 250 songs. Our equation that we're going to write will look like the absolute value of x minus 2,000 equals 250. This is a rather simple equation. Most of the equations you're asked to write for absolute value expressions will generally be simple equations to begin with. Now let's talk about solving. I see that since my expression equals a positive number, I'm going to have two solutions. Since my expression equals a positive number, I'm going to have two solutions. To find those two solutions, we break it into two separate cases. Case 1 is we keep the entire equation exactly as it is, we just get rid of the absolute value signs. So we'd write x minus 2,000 equals 250 and solve that. Now, you guys know how to do that. We add 2,000 to both sides using our addition property of equality, and we'll get the 2,000 and negative 2,000 canceling. We're left with x equals 2,250. I'm going to put songs there just as an additional reminder that we're talking about songs. That's case 1. This would be one possible answer. Case 2 is the value we could be getting from this could be a negative number. If we were to subtract these, we could have a negative number that its absolute value would be 250. Which means the absolute value, which means this value inside could actually be negative 250. That's going to be our other situation. Whenever you're solving absolute value equations, if you've got a positive number on the outside to begin with, case 1, you'll have a positive version and you'll just get rid of the absolute value signs. Case 2, you'll change the number to a negative on the outside and keep the absolute value signs. Those are the two things you have to do. Now, luckily, if we can solve case 1 by adding 2,000, we have to do the exact same thing here. Add 2,000 to both sides. We'll get x equals 1,750. We've got a clearer upper and lower amount of songs. We've got a maximum number of songs the phone could hold and a minimum number of songs the phone could hold. And we're going to make sure to graph this by graphing just 2 points. If I'm trying to graph this, normally I make things easy for myself, and I'll place in the middle the number I was adding or subtracting, in this case 2,000, and I'll count up by some amount. So I'm going to count up by hundreds. 100, 200, 300. I'll mark this as 2,200. And I'll count down. 1,900, 1,800, 1,700. And I'll put a dot halfway between 2,200 and 2,300, and a dot halfway between 1,800 and 1,700. Those two dots would be our solution, would be a graph of our solution set. You'd want to try something similar here. Going on. We have another quick example here, zooming in a little bit more. For example 2, this is going to be a common thing you could imagine. Jake has cash in his wallet, but he doesn't know the exact amount. But he has a reasonable guess. When his friends ask him how much he has in his wallet, he says he's about $50, more or less 15. We're going to write an absolute value equation to model this situation, and we're going to then figure out how much money he could have had in his wallet. Well, the absolute value equation we're going to write is he doesn't know how much money he has to begin with, but he has a prediction, so we're going to use our equation. We're going to write our real amount minus the predicted, minus the $50. In absolute value should equal how much he's possibly wrong. He's possibly wrong by $15. So we'll put 15 there. Now, we don't have to write case 1, case 2 in this case, because you can probably already answer how much he might have in his wallet. He thinks he has $50, but he could have $15 more, meaning he could have $65, or he could have $15 less than 50, which means he could have $35. We could find these by doing the same sort of case 1 and case 2 situation from before. Let's take a look at example 3. It's extending the idea of absolute values to margin of error. Commonly in surveys and polls, you'll see estimates of error or margins of error. We're going to sort of deal with that here, and a little bit of proportions as well. A table shows the results of a survey that asks what the most important benefit of air travel in the future would be. There are about 40 million students in the US. If the margin of error in the survey is plus or minus 3%, our question is, what is the range of number of students who would say that finding new resources for Earth is the most important benefit? Well, we've got some percentages that were measured in the survey, but because we're not surveying everyone, we could have a little bit of error. They incorporate a little bit of error and say, hey, we didn't survey enough people, we could be off by about 3%. So we'll incorporate that idea to give us a range. We'll start off with the 21%, and we'll go with started with 21% because they're interested in finding resources, but they could have been higher. It could have been 3% higher, so we'll go plus 3%. So the number of people who really think aviation is going to be about finding new resources for Earth, that could be maybe 24% of people surveyed, or 24% of students. So to deal with that fact, we're just going to multiply our 40 million times 0.24. 24%, if you want to use percentages in your multiplication, need to be turned into decimals. So I turned the percentage into a decimal, and I'd multiply 40 million times 0.24. I get about 9.6 million. So this would be an upper limit for the maximum number of students who might think that finding new resources for Earth would be the most important benefit of air travel in the future. Going the other way, we could have had actually 3% less than 21%. It could have been 18% of students actually think finding new resources is the most important. So we'll think about 40 million, and we'll think about 18% of 40 million, which means we're going to do 40 million times 0.18. That would be, for us, 7.2 million students might think that the finding new resources for Earth is the most important thing in the future of flight. One last thing that is an aside, just something that I don't think is as important but might come up, is how to write an equation involving absolute values for the graph. The process for doing this is thinking about where the middle is. I see these 2 points, 17 and 27. We're going to find the halfway point. Basically, we're going to find the midpoint. Find the point halfway between (17) and 27. It's called the midpoint. It's the midpoint. Which is 22 in our case. 22 would be considered like our average it's the predicted amount. We'll plug that in a minute. So I'm going to put just a brief circle around the point where 22 would be. And we're going to then find the distance from 22 to either side. So from 22 to 27, we'd be adding 5. From 22 to 17, we'd be subtracting 5. Since we could either be adding or subtracting, those are going to be the numbers on the outside of our absolute value sign. Our equation is going to look like, remember, it's our real number minus we might call it the midpoint, inside of absolute values equals our distance. I'm going to call that the distance. We could be 5 away, either in the positive direction or in the negative direction. Our equation here is going to look like x minus 22 inside of absolute value signs equals 5. That was the notes for today. There is a homework assignment 1-4 that is paired with it. It is 7 questions you had some time to work on today with Mr. G. I heard you did a handful together. Have a good day. Look for the next video on seeing the Now You Tries for your check.